So I wanted to do an example of an RL circuit. So what we're going to do is we're going to consider an RL circuit as follows. So let's consider we've got a battery, have a switch, resistor R1, we have a resistor R2, we have an inductor L, and let's say that R1 is going to be equal to 25 ohms, and let's say that R2 is going to equal 750 ohms, and then let's say that the inductance is 0.355 henries. And let's say that the voltage over here, V naught, is going to be 17.5 volts. And so we're going to say what happens when you first close the switch. What happens? So first step, when you first close the switch, then current starts flowing this way, and well, the resistor is fine with current, but the inductor resists current flow. So step A, when you first close the switch, then we can call this I1 and I2. I1 is 0. The inductor resists current flowing, so no current initially flows on that path right there. But as soon as there's voltage, then current starts flowing in resistor 2. And so what happens is you get 0.023 amps, 23 milliamps. I2 is going to be V naught over R2. You plug the numbers in, you get 23 milliamps. And so that's the instant you close the switch. Now, a fraction of a second later, then current starts flowing here. So the next question is, how long does it take until I1, or let's say the next question is after a really long time, then what's the current? So B. So after a long time, then the inductor just acts like a wire. And so all we have is I1 is going to be V naught over R1, I2 is V naught over R2, and so I1 is going to be so I1 is going to be 0.7 amps as flowing down, and I2 is still going to be, it doesn't change, so it's going to be 0.023 amps, and it's also flowing down. So, third question, how long did it take until the current I1 was half of its maximum? So how long it's half the max. So we know that the current, as you're increasing in the inductor, is going to be I naught in this case is I max, times 1 minus e to the minus t over tau. So if I is half of I naught, so I equals 1/2 of I naught, so if I plug that in, then what we have is 1/2 I naught equals I naught 1 minus e to the minus t over tau. The I naughts cancel. We do a little algebra here, and e to the minus t over tau is equal to minus 1/2. Sorry, not plus 1/2. Okay, and then we take the natural log of both sides, so minus t over tau is natural log of 1/2. So t is going to be minus tau natural log of 1/2. So what's tau? Tau is L over R. So in this case, it's going to be equal to 0.355 henries divided by, well, the only R that's affecting it is the 25 ohm R. And so that means that tau is going to be equal to 0.0142 seconds. So if I plug that into the previous equation, so T, which is equal to minus tau natural log of 1/2, if I plug that in, what I come up with is 9.84 milliseconds. So that's how long it took until the current got to be 1/2 of the maximum. So for my next part D, we had the switch and it was closed, okay, and so as the switch is closed, we get R1, we got L, now we have R2 right here, okay, and now I'm going to open the switch. So if I open the switch, then what happens? The instant I open the switch, what's the current? Well, the inductor keeps the current flowing. Well, if the current's flowing, the only complete path is this way. So that means that the current in R1, so this is going to be I1 over here, and this will be I2 over here. So I1 is the same as it was before. So you have 0.7 amps, and it's still flowing down because the inductor keeps the current flowing the same way. I2, however, is now 0.7 amps. It's flowing up because the inductor is forcing the current to flow the same way. Well, if I ask for what's the voltage on each resistor, V equals IR. So the voltage on 1 equals I1 R1. So that would be 0.7 amps times the 25 ohms, and that's going to be equal to 17.5 volts. But V2 is going to be equal to the 0.7 amps. So that'll be the 0.7 amps times the 750 ohms. So that's going to be equal to 525 volts. Okay, so all of a sudden you have this voltage spike. This is not exactly, but similar to the sort of diagram as to what's happening in ignition system of a car, in which you get the ignition coil, that's the inductor there, and when the magnetic field collapses, releases its energy, and you get a spike in voltage. But this is kind of how you get this high voltage here, even though the original voltage you had to supply was only about 17.5 volts. And so that energy was stored in the magnetic field. So now the next question is, after a long time, after you open the switch, what happens? Well, all the energy is dissipated. And so after a long time, I1 is 0, I2 is 0. Okay, so the next question, F, would be, okay, so how long did it take until the current dropped in 1/2? So I want to know I equals 1/2 of the I naught. Well, as the current's dropping, we know the equation is I equals I naught e to the minus t over tau. So 1/2 I naught equals I naught e to the minus t over tau. The I naughts cancel, so take the natural logarithm of both sides and bring the tau across. And so that would tell us that t equals minus tau natural log of 1/2. Now, what's tau? Tau is L over R. Okay, so but it's the same. It's the exact same inductor. So 0.355 henries. But R is now both resistors, because now if you look at the circuit, we've got R1, we've got the inductor, we got R2, so the current is going through both of them. So the R in the circuit here is going to be R1 plus R2. So that would be 775 ohms. So now the tau, in this case, as we're collapsing, is going to be equal to 0.458 milliseconds. Okay, and so we plug that in. So T equals minus tau, natural log of 1/2. So this will be 4.58 times 10 to the minus 4 seconds, natural log of 1/2. So the time is going to be 3.18 times 10 to the minus 4 seconds. Or in other words, that's going to be 0.318 milliseconds. So that's how long it would take for the current to drop to 1/2. So this is an example of an RL circuit. The instant you try to change the current, the inductor keeps the current from changing. So if the current is initially 0, the instant you try to change it, it stays 0, and then it gradually builds. If the current is flowing, the instant that you try to stop it, it stays the same, and then it gradually drops. How gradual depends on the resistance and the size of the inductor. So hopefully that gives you an idea as to how to use RL circuits.